Alright folks, here at atlasrfidstore.com we get a lot of questions about what can I do to optimize my RFID system's read range. And it's a good question, and we spent a lot of time answering it, so we decided to make a video to help our customers out. Some of the main factors deal with the type of antenna you're using. And the first thing I want to talk about is antenna gain. If you have a system where you want to get really long read ranges, then it's good to consider using a high gain antenna. That could be anywhere between 9 to 10 dBs. So the thing that some people ask is, why would I ever want to use something other than a high gain antenna? And the short answer is size. High gain antennas tend to be bigger than the small gain antennas, which depends on if you have a system where size is a constraint, you might need to experiment with some lower gain antennas. Or if you don't need to have very long read ranges, you can get away with a smaller antenna. The second thing that can affect your read range that deals with antennas is your antenna's polarization. In general, polarization refers to the way in which your antenna is transmitting its power. Linear antennas are really good at cutting a single plane through the air. Circular polarization will get a tag even if it's not directly in the straight plane of the antenna. So linear antennas are going to be able to read further distances, but they're much more limited in the way that the tag can be oriented. In a linear system, the tag needs to always be coming across the antenna oriented the right way. If you're set up like this might affect your read range depending on if it's linear or circular. So to summarize, linear polarized antennas are going to get you further read range as long as you can control the orientation of the tag. However, if you can't control the orientation, you're going to be better off with the circular antenna. Alright, the next thing that I wanted to talk about deals specifically with RFID tags, and we've come up with a little acronym TAG SOAP. Tag size, tag orientation, tag angle, and tag placement. So we're going to go in that order. Tag size is one of the biggest factors that's going to affect your read range with your system. And here's some examples. This tag is going to have a lot further read range than this tag. I don't know if you can see those very well, but here we've got an Omni ID tag, and this is a small Xerify dot tag. And depending on the size, you're going to have huge differences, anywhere from 20 feet to 25 feet to a matter of inches. And this is all dealing with UHF tags. So the next thing is tag orientation. And we've already kind of talked about this a little with linear antennas, and this specifically does only pertain to linear antennas. But if you change the orientation of the tag, here's the antenna, here's the tag, this is the kind of movement that I'm talking about. And with a linear antenna system, that's going to make a big difference in your read ranges. However, if you're circular, this shouldn't matter too much. That leads into the next factor, which is read angle. Specifically what we're talking about there is this kind of movement, this kind of orientation. And this doesn't matter, linear or circular. If you change this read angle much, you're going to see a decrease in the read distance. So ideally, tags are facing each other like this, and you're going to get the best read ranges. And the last thing dealing with tags is tag placement. And factors to consider are you putting this tag on metal? Are you putting this tag in a high liquid environment? Those things are going to affect your read ranges. So make sure you get the right tag for the job depending on where you want to put it. The next thing I want to talk about that affects your read range is the reader power settings. And it's important to remember that an increase or decrease of 3 dBs will double or cut in half your reader power, but your antenna power, but that does not mean that it will double or cut in half your read range. So just keep that in mind as you're changing your reader power settings. It's important to go in there and fit that to your application. A high read power setting will give you the best range you can get, but sometimes you don't want a super high read range. You might be trying to actually control and limit the tags that you're reading, maybe in a conveyor belt setting. So keep your reader power settings in mind. Alright, the next thing I want to talk about that affects your read range is the type of cable that you're using to connect your reader to your antenna. And these are two basic examples that I brought to show you the difference. This cable would be great for anything up to the point of about 20 feet, plus or minus. We always recommend testing, but that's a good rough estimate, about 20 feet. Now, anything beyond that distance, you're going to need to start thinking about insulating your antenna cable a little bit better. And up to a point where you could have this much of a difference in the type of antenna cable that you're using. So the other tip about antenna cables is to use as few adapters or ports as you can, because every time you add one of those on, that's going to add loss in between your reader and your antenna, which will decrease your read ranges. Alright, the last thing I wanted to tip you off on read range is your environmental setting. Where are you putting the system? Is it a place where there's a lot of metal? Metal is going to reflect UHF RFID energy, and that's going to make it unpredictable as far as where can I place my antenna to get the best read range. The other factor is water, which will absorb RF energy. So keep those two factors in mind, and always remember that testing is the best way to decrease the possibility that you're going to have problems with those two things. Hope this video was helpful. If you have any questions, comment below or email us at info@atlasrfidstore.com.